Okay, Unit 5 study guide. Number 1, square root of 16 is 4. Okay, number 4 is the square root of 18x to the third. So the question you ask yourself is, what perfect square root goes into 18? And that would be 9 times 2x to the third. The square root of 9 is 3. Number left over is 2. And then you say you have an index number here of 2. 2 goes into 3 how many times? Once, remainder 1. So again, your answer is 3x. And then square root of 2x for a final answer. Okay, number 5 is a cube root problem. So this is the cube root of 16x to the 5th. Cube root, so cube root list. What is the cube root that goes into 16? You should be saying 8. So we make this 8 times 2, x to the 5th. Cube root of 8 is 2. Number left over is a 2. And then 3 goes into 5 how many times? Once. Remainder 2. Put your cube root up there. And you are done. Number 3, square root of x to the 5th. So the question you ask yourself here is, how many times? This is really a square root, right? So I say 2 goes into 5 how many times? Twice. Remainder 1. Number 6. Okay, recycling bin. That's fine. You can laugh when you watch it. Number 6. Cube root of 24 x to the 7th. So cube root of 24. The perfect third root that goes into that is 8 times 3 x to the 7th. Cube root of 8 is 2. Left over is a 3. And then we say 3 goes into 7 how many times? 3 goes into 7 twice. Remainder 1. So final answer, 2x times the cube root of 3x. All right, number 10.
Is that, wait, question.
Yes,
is that 8? Because it's kind of dark. Is that 18?
That's a 10.
Oh, I get it now. Why would you do that?
You guys put your hand in the air, so let's just do it. So cube root of 54 x to the 7th y to the 10th. All right, you guys go ahead and talk here. What's the cube root of 54? What cube root goes into it? What is it? 27. All right, so 27. All right, 27 times 2, x to the 7th, y to the 10th, and that's a cube root. What is the cube root of 27? 3. Number left over is a 2. 3 goes into x to the 7th how many times?
2.
Twice. Remainder 1. 3 goes into y to the 10th. 3. Put my cube root up here. Remainder 1. All done. Easy?
Oh, yeah, Mr. Baker,
Good.
question. I need to ask you, I know it's an easy question, but I need to ask you this so I don't get it wrong. It's going to be a dumb mistake.
All right, go ahead.
Hey, you know
You're on film here, Phil, so be careful.
Oh, my bad. I'm sorry.
No, you're good. Go ahead.
You go to 27. How did you get 3 on the outside again?
I said, what is the cube root of 27?
You look at the index number first?
Yes.
Yeah. Okay.
So you say, what is my index number? Since it's a 3, I say, what cube root goes into 54? That is a 27. My whatever number is a 2. And then I say, what is the cube root of 27? It's 3. Left over is 2. Then go through and do the letters.
And you'll know that just by memorizing your
Cube roots. So if I say, what are my cube roots? I say they are 1, 8, 27, 64, 125. That's really 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. These are the third. You good? All right. I'll put it on the video. 13. Shh. Guys, quiet down. 13 is 3 to the negative 4, which is really 1 over 3 to the 4th, which is 1 over 81. We'll just keep right going here into 14 is 2/3 to the third. So when you raise a fraction to a power, you raise the top and bottom. Good. So that's really 2 to the third, which is 8, over 3 to the third, which is 27. Good. 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 Joey, good.
Mr. Baker.
Okay. Phil,
Where I can talk now is the video. I mean, I'm still talking.
you're still talking. You're good.
All right, you did. What did you did? to get the 8 over 27, what you do for that one again? When you do 3 on the outside.
I do 2 to the third
That, like,
over 3 to the third, and 2 to the third is 8, and 3 to the third is 27.
So you did 2 times 2 times 2.
That's right.
You got 8.
Uh-huh. 3 times 3.
Same thing at the bottom.
Exactly. Mm-hmm.
Yeah, we can do it now.
All right, 16. A, B, C, A, B, C. A is -2 to -4, 5, -1, 4, 2. Okay, negative exponent tells us to do what? Flip it. So this becomes a to the 4th over a squared. I take my b to the -1 down here and flip it up. So this is b to the 6th. And my c's, I have 4 up top, 2 on the bottom. So I have 2 up top. Need to do what with my a's? I have to
You gotta, it's going to be 2. You flip them.
not add. I want to cancel them, right? I have 4 up top and 2 on the bottom. So this becomes a2 and then b6, c2. And if you want to put it over 1, that is fine.
Oh, Mr. Baker, hold up before you do anything. Hold up.
Yes, Phil.
All right, I got to come to the action. So could you, to do that, could you do it like this? Hold up.
Got Phil joining us here, please.
Like, is this like the same?
No one's gonna see it on the board. You can write it.
No, I don't. I'm just saying. People say it. I want you to see it. Like, is this the same method like this?
Yes, same exact
And
thing.
you had the 2.
Yes. So what Phil is drawing on the board here is this,
Okay, I understand. Gotcha.
and then we say you can cancel that with that and that with that. So that's a squared. Okay, make sense? Number 17. 3x squared y, that whole thing to the 0, all over 2x to the -3rd. So up top, anything to the 0 power is 1 over, and what are we going to have down here? 2 to the -3rd, x to the -3rd, and those negatives tell us to bring them up to the top. So 2 to the 3rd is really 8, and then bring up our x to the 3rd. Okay, number 19, 2x to the -2, all over y to the -4, that to the -2. So we distribute this -2 everywhere, right? Top and bottom. So this is 2 to the -2, x to the power to a power, we multiply, but a negative times a negative is a +4. And on the bottom, we're going to have y to the what? +8, good. Because -4 times -2. Good up to that point?
Yep.
Yes? All right. The only thing here that's negative is the 2 to the -2. 2 squared is 4. Negative tells me to flip. And we're all done. Okay. Okay, 22. 4 radical 18 plus 2 radical 50 minus 3 radical 72. 18, these are all squared roots, so I'm looking for perfect squares. Joey, what perfect square goes into 18? 9 times 2. Israel, what am I doing for 50? Which perfect square goes into 50? Somebody help her. Someone help her. We're on video. 25. Okay, good. 25 times 2. And the last one. Very good. 36 times 2. Okay. Square root of 9 is 3 times 4 is 12 radical 2 plus the 5 from the 25 times this is a 10. And this one is a 6 times 3 is. Now, we have all the radicals the same, right? Because to add and subtract radicals, what are the 2 rules? We need what 2 things to have happen? The index number has to be the same. And so does the number underneath. So you need the same number under the radical, and they have to all be squared roots or all be cube roots. So originally, we just had the same index number. And then by breaking them down and simplifying them, now we have the same number underneath. So what do? I just add and subtract the outside number. And 12 plus 10 is what? 22? And 22 minus 18 is? Somebody? 4, okay. 4 root 2. Good? Any questions? Okay, good. Number 24, going to rationalize. Problem is 1 plus root 3 over 2 minus root 5. Claudia, explain to me what it means to rationalize. Am I going to add, subtract, multiply? What am I'm going to change this to an
I
add.
mean multiply. sorry.
Multiply, and this changes to an add, right?
Yes.
Okay, good. So I'm going to multiply by, tell me what I'm going to write here.
2 plus square root of 5.
And on top,
And then the exact
same thing. All right, Joey, what do I do with these things? 1 plus radical 3 and 2 plus root 5.
Foil.
I foil them, good. So when I come over here and I foil this, first times first gives me 2. Outer gives me
1 with 5.
plus radical 5. Inner gives me
Plus 2 with 3.
2 root 3. And last times last gives me
Root 15.
root 15. On the bottom, first times first is
4
outer,
minus 2 with 5.
no, outer, plus 2 root 5. Inner, minus 2 root 5. And last times last,
5.
what kind of 5?
Positive. Negative.
Negative, there you go. And on the bottom, can I cancel anything out?
Yes, the middle.
Middle 2. So final answer. All the stuff from the top. And then on the bottom, what do we have on the bottom?
1.
This is a 15. And on the bottom we have negative 1.
Negative.
Because 4 minus 5. Yes?
When you rationalize it, what tells you how many times you have to, like,
Well, in this case, we're just trying to get, we have like a binomial on the bottom, 2 things, so you're just undoing it by changing it to a plus. Now, if you had like a cube root by itself, which you're going to see in number 26, that's the one where you're going to do it an additional time. So let's just skip to 26 while we have this conversation going.
You're always gonna do the bottom, but it's always gonna be plus though, right?
Yeah, you change the symbol. So to answer your question, while this is still recording, let's just skip right to 26. 26 says the cube root of 4 thirds, okay? Which is going to be equal to, if I split this up, the cube root of 4 over the cube root of 3. Okay? So to fix this now, Joey, what do I do?
You take that and you do it with the
So this is 1, 2, 3. And then up top I match it, right? Good.
Oh, yeah, okay.
So why do I do that? Because on the bottom, what does this create?
The index number is
The-
3, right?
The index number is 3, so I do it 3 times. And the reason is because on the bottom, this is going to create the cube root of 27, which I can take, and that becomes a 3. Then up top, what do we end up with? 4 times 3 times 3 is what?
4 times 3
36. Good. So the cube root of 36 over 3. Does that make sense? Now, if it was a square root, we would only do this twice. In other words, we would have just done that part there that I put a box around. Since it's a cube root, we do it 3 times. Yes?
Make sure we go to 25.
I will go back to 25 next. All right, 25. We're going to rationalize the square root of 1/2. This is an index number of 2. We're going to split it up and say this is the square root of 1 over the square root of 2. The square root of 1 is 1 over the square root of 2. To fix this, we're going to multiply the top and bottom by what?
The bottom.
Which is what?
The root 2.
Square root of 2.
Because you have to get rid of it.
This gives me then what? The square root of 2 over the square root of 4, but the square root of 4 is 2. Answers.
You did the square root at the bottom, and the square root of the bottom was 2, right?
The square root of the bottom was the square root of 4, which is 2.
I'm saying all those are 2s, though, right?
Yes.
That one, that one.
Yes.
And the top is what now? Like, what's the final answer?
The square root of 2 over 2 is your final answer. Number 30. Solve the following radical equation. 2 plus the square root of 3x minus 2 is equal to 6.
Hey, Paul, you knew this video? What?
We're going to subtract 2 from both sides.
No, you could buy.
No, it's not a multiplication. This is a division. This right here, when you see that plus symbol, that tells me the opposite of that is to subtract. So we want to subtract our 2 from both sides. How do I get rid of a radical? To undo a radical, we square both sides. When you square the left, you have 3x minus 2. When I square the right, I have 16. Now you just solve your equation, right? So add 2. 3x is equal to 18. X is equal to 6. We good? Any questions? Okay. Okay, number 32. 3 times the quantity of x minus 2 to the 2/3 power equal to 75. Now, this is one where you divide, right? There's no plus symbol in there, so we're going to divide by 3. X minus 2 to the 2/3 power is 25. How do I undo this 2/3 power?
You switch them and multiply both sides.
I'm going to switch them. What do you mean by switch them?
X1 and 2 for each of you.
Yes, I raise both sides to the reciprocal powers. In other words, I take this power and I flip it. So when I raise this to the 3/2, I have to do it both sides. So now when on the left side, when I raise this to the 3/2, what is this? 6/6, and 6/6 is really cancels. It just gives me 1. So this is x minus 2 is equal to. How do I do this? 25 to the 3/2 power. What is the square root of 25?
5.
To the 3rd power is what? 125. And then what do I do with that minus 2? I add it over. X is equal to 127. Make sense? Okay.
Hey, so, Mr. Baker, you took the 3 over and divided, right?
I'm sorry, what's that?
You see that
To begin with?
You divided.
Yes, you divided both sides by 3, and that's how 75 turned to 25. Okay, 34 is our composite function question. They give us 2. F of x is equal to 2x squared plus 3x plus 4, and g of x is equal to 2x plus 1. First thing they ask is for us to add these. So f of x plus g of x, just add your like terms. 2x squared, over here there are no x squared terms, so it just stays 2x squared. 3x and 2x is 5x, and 4 and 1 is 5. Next one is for us to multiply these. F of x times g of x. So this is really, let's write the g of x one first, it's the smaller one. 2x plus 1 times 2x squared plus 3x plus 4. This is back like in Unit 4, remember when we multiplied these? So I underline this one here, and I distribute the 2x through it, and then I distribute the 1 through it, and then combine our stuff. So if I distribute the 2 through it, 2x into everything, this is going to be 4x to the 3rd plus what?
6x squared.
Good. Plus
8.
8 what? Good. And then I take this 1 and do the same thing, but anything times 1 is just itself, right? So plus 2x squared plus 3x plus 4. Looking for like terms. 4x to the 3rd,
8x
6x, and 2x give us 8x squared. 8x and 3x is 11x, and left over at the end is the 4. Part C says find f of 2. Means I go up to my f function, right? And it says 2x squared plus 3x plus 4. We think of that as the blueprint. But instead of x, what am I going to plug in there? 2. And then we do the math. 2 squared is 4. 4 times 2 is 8 plus 6 plus 4. 8 and 6 is 14, and 4 more is 18. Part D, f of g of -1. Means I plug -1 into g. What does that give me? 2 times -1 is -2, and -2 plus 1 is -1. So I take that -1 and plug it into f. So 2 times that squared plus 3 times that plus 4, and my that is -1. -1 squared is what? 1, and 1 times 2 is -3 plus 4. 2 minus 3 is -1, and -1 plus 4 is 3. Good. Last one, part E, asks for g of f of x. There's nothing to plug in here now, so I just take the whole f function and plug it into g. Let's make a blueprint for g. It's 2x plus 1, but instead of my x, I'm going to plug in 2x squared plus 3x plus 4. That's the f function, right? So then distribute. And what does that give us? I'm out of room, so draw an arrow over here. 4x squared plus 6x. 8 plus 1, so 4x squared plus 6x plus 9. Sorry, I'm off camera. All right. Probably just want to pause this when you're watching it at home, so you can go ahead and see what you have there. Make sense?
Yes.
Good. Okay, that was 34, 35, 37, 38. So now we're on 39. 39 is the inverse question. It says, find the inverse of the following. Y is equal to x squared minus 5. And again, the inverse, another way of writing the inverse is f and negative 1 of x. So to find this inverse, we do what? We switch the x and the y. So this is x is equal to y squared minus 5. So x plus 5 is equal to y squared, bringing that 5 over. And then how do we finish this? We do, good, square root of both sides. So the square root of x plus 5, and we're going to call it plus or minus, is equal to y. Okay? Number 40. Find the inverse. This is very similar to the last one. So the inverse of y is equal to the square root of x minus 4. Instead of y and x, I'm going to flip them and make it an x and y underneath. How do I undo a square root? I do what to both sides? Square it. So x squared is equal to y minus 4. I want to solve it for y by doing what? Plus 4. X squared plus 4 is equal to y, and we're all done. All right, 41. So look to 41 in your packet. It says, given f of x is equal to plus or minus the square root of x plus 1. Okay, the first thing they ask for is the domain and the range of this. So what does this look like? It's a square root. So let's draw a graph here. It's a square root shifted 1 to the left. So I'm going to make a line here. That's my starting point. If you know what it looks like, we can make a rough sketch. If you don't know what it looks like, we make a table and plug in the values, right? So if I just made my rough sketch, we know it should look like that, right? What does that tell me about my domain? My domain is my left and my right, my x values. So what's the smallest possible value I could have here? Negative 1, and it goes all the way up through infinity. So my domain is going to be negative 1 to x to infinity. Now my range, my up and my down, as time goes on, this graph just keeps going up and up and up, and also down and down and down. So we would say my range is what? All real numbers, or another way of saying that is negative infinity to x to infinity. Okay, then the next part of this question says, find f of negative 1 of x. And what is f of negative 1 of x? That's another way of saying the inverse. So how do I find the inverse? Instead of f of x, and f of x is the same thing as saying y. Right. So x is equal to plus or minus square root of y plus 1. Solve this for both sides. So what the both sides? Do square both sides. Good. So x squared is equal to what? Y plus 1. Subtract that 1 over. So x squared minus 1 is equal to y. What does that graph look like? That is a quadratic shifted 1 unit down. Again, you could pinpoint this better with a table. That's your sketch. What's my domain now for this sketch? Negative to positive what? Infinity. So all real numbers, or negative infinity to x to infinity. My range is what? Negative 1 to y to infinity. And what do we notice here? My domain and my range, the domain of the first one is the range of the second one, and then likewise the range of the first one is the domain of the second one, which should make sense, right? Because you switch the x and y values when you find the inverse, therefore you flip-flop the domain and range as well with it. All right, last one, 42. Going to try to graph f of x is equal to the square root of x. So first thing I want to do is make a table if we don't know what this looks like. I want to pick good values for x. So what are good values? I can pick 0 because I can take the square root of that and get 0. I can pick 1, it gives me 1. If I pick 2, can't take the absolute value of 2. If I pick 3, same thing. If I pick 4, that works. Next good number would be a 9. I can't pick negative 1 because I can't take the square root of negative 1, so there can't be anything up here. So when I go to graph this, what do I have? 0, 0, 1, 1, 4, 2. Go all the way down here, 5, 6, 7, 8, 9, 3, and then you get an idea that the graph looks like that. That's the plus side. If I was to do the negative of this, so plus or minus, it means you just take these values and mirror them. So you'd have 1, 2, and 3, and this would be plus or minus the square root of x.